Uh, Greetings, everyone. So our project is called ZombieHunter. So we built our project on the problem statement zombie and shadow API discovery for public sector banks. The core issue what we are solving is that large bank often have thousands of API, and many of the time those APIs are left untouched, but those APIs are engraved into the system that much that it gets old, and for a hacker it becomes a loophole. So so to see whether the API is a zombie API or the API might become a zombie API, we made a system in which it will monitor the APIs throughout the system regularly. It will show on the dashboard whether the API is orphaned, whether uh, it is being orphan means it is being used but not what do you call not touched for a long time. And these orphaned APIs generally become zombie APIs. So yeah, and whether the API might become zombie API. So as you can see, this API became zombie API. So currently we didn't have any live data source. So this is all synthetic data, but this can be pivoted to a live data source also. Uh, it also says that this API might become a zombie API, so it is under review. As well as we have made a dashboard to make it easier for the reviewer or the engineer to evaluate all these things. Now this is our inventory. So this will consist of all APIs which is present in the system. So you can see whether the risk is low, risk is high, whether it is active or not, whether whether it can become a zombie API or not. See, now one more thing. So we have also made a queue whether if it is an anomaly, and if the engineer have to review that. So this will have a dashboard. So ML telemetry. So we have trained three models. We'll come to that in the further tasks. So this is everything which is generated. One more thing we have added is a very small language model, which is Quen 2.5 billion parameter one. So all these reports for very clear and very deep review for what the API is doing and why it is flagged as orphan. Uh, this is all backed up by the ML model which we have trained. So whatever data is going into the language model, that is our predicted data. That is not any rubbish data, along with the API details. And also we can generate all these things. And this is again a dashboard. We have made this dashboard so that it is very easier for the engineer. Also the confidence, since the confidence is low, this risk is medium, and this confidence is generated again by our regression model. Now let's jump to our models. So these three models we have trained as of now. uh, So this is a classification model. It says whether the API is active, depreciated, or orphaned. So again, the life cycle, and since if the API is orphaned, then it might become a zombie API. Similarly, the risk score. So from the API data collected, which can be collected from the live source, whether it can be a Docker container, and also also it can be fetched from Kubernetes containers, or Kubernetes logs also. And again, anomaly detection, whether it is a time series model, so it can predict that whether our model can become, whether our API can become a zombie API in the further stages or not, so that we can take precautions beforehand only. Now, another thing for the ease of the reviewer, we have made this graph dashboard also, and this is in practice. Now, boreholes. This is the main part of our project, in which, see, suppose this borehole, if I go back, this borehole, so you can directly fetch data from the Docker container. Since we don't have a running Docker container as of now, because we don't have any live websites running, we can make anything and we can deploy it. Again, it is running on synthetic data, so it will generate. Also, we have connected this to the SLM also, so that we can talk with the SLM and see whether what problem is there, so that we can solve it. And here it is, the anomaly detection model is working in, which is predicting whether it can be depreciated or not. See, suppose transfers, you can see here, this is the live logs. So transfers, you can see here, many of the times it is showing some not for 400 error, which is the user side error. And yeah, similarly, then now the last part, the reports. Again, given every data of the website, every live logs, the SLM generates a very short report of what is the thing, what is the issue. See, suppose this is the issue, and then how it can be resolved and everything. We can generate it. Also, let me run a discovery scan again. So yeah, so this is coming from another file, another live source, and see, it changes everything. So yeah, this is pretty much it. In the further future, we can, uh, for a particular bank, we can link it, and banks can use to determine whether their APIs are going to die, or whether their APIs are going to get depreciated or not. And yes, and the SLM part, it would make it quite easy for the person reviewing all these API to solve that zombie API issue. And also one more issue that several banks face is employees leave, who made the API, which is deeply engraved in the system, and documentations are very hard to find. So this SLM can also generate the documentation and the API reports, so that it can be solved properly. This is it. Also, for the evaluators review, since SLM is a large file and cannot be deployed on the free version of Render, so we are currently deploying our three ML models, these three ML models. So you can still see all these things. Uh, you can still see boreholes and all. You can still see that, but this thing might not come. And again, these reports might not get generated. And these things, some of these things will come, but everything won't get generated. Thank you. This was our project. Hope you would have liked it.